Hey, this is Mr. Mitchell with a video. I'd like to talk a little bit more about electromagnets, and I'd like to talk a little bit about simple motors, and I'd like to talk a little bit about generators. So first, electromagnets. We've touched on electromagnets, but as a reminder, an electric current can be produced in a circuit by changing the magnetic field, and here's what we have. We have a battery or some kind of flow of electrons which goes through this wire, goes round to the end. It completes a circuit by putting some sort of conductor in there, like a nail. You can make this nail magnetized, and it increases the amount of electricity that goes through here, and this is what's called an electromagnet. Now, you can also make, you have a north end and a south end to this magnet or this nail, which turns into a magnet, but you can flip-flop the north and the south end by changing the electricity that goes through, by changing the direction of the circuit. So we figure that out on how to do it on a small scale, of course, with a nail and a battery and wire. But you can see we have a similar setup here. We have much more tightly wrapped around cord. You have more electricity going through here, which only magnifies the electricity. And we have a conductive metal bar which goes through here, and you have the source of power coming from down here. So it makes for a stronger magnet. It makes for more electricity the more wires you have, and it makes for better magnet the bigger magnet you have. It just kind of is a power pack right there. Now, we actually use these a fairly good amount here on in our society. This is a speaker, and you can see the magnet. This big yellow thing is a magnet here, and we have the coiled wires here, and we have the electricity that goes through here. So the electricity that comes from the socket actually goes through here, and you make changes. You probably have some kind of rotation of either the wires or the magnet to have that change of current. Remember, this is alternating current here, and it powers the speakers. Here you have this big magnet which would like pick up things in a junkyard. Now, since this is an electromagnet, if you break the circuit of electricity, this big thing is not magnetized anymore, and all of that will fall down. So if you were to pick up a whole bunch of metal junk with this super huge magnet, and you could move it over to where you're putting it, you just cut off the electrical power, and all of that falls down because it's not a magnet anymore. Here's a setup with an old-fashioned bell, and you can see we've got the coils. You have the coils of wire, and you have something that goes through it, which is a conductor. Put electricity through the coils, and you have an electromagnet right there, and you can see how it controls the bell. These maglev trains, we've talked about it being magnetized, but you have this train track here which is magnetized, but it would not be practical if these things were magnetized all the time. I mean, can you imagine all the metal debris which would fall on them and stick to them if they were always magnetized? But with an electromagnet, you can control when things are magnetized and when they're not. So if you have the bottom of the train that is repelling this magnet, or you have the similar ends, then you can push the train along by suddenly magnetizing the front and then demagnetizing the back track. So it pushes it along, and you can control the magnet through the electromagnet system. You just have to stop the flow of electricity, and suddenly there is no magnetism anymore. So that's kind of some practical uses of an electromagnet. What is a simple electric motor? A simple electromotor has some similar things to electromagnet. You see you have a power source, you see you have a magnet, and you see you have coils of wire. So when you see something that's a simple motor, it is an electromagnet. What happens is, you may remember, you have to change the fields, change the magnetic fields to alternate the electricity. And what happens is, you can see this case, they're moving the wire, go from flat to straight up, flat to straight up, flat to straight up, flat to straight up, and that constantly changes those fields and produces more and more electricity. And here we have it on a very small scale, but we also use these very commonly in things around the house. I mean, you have to have a motor in here, in this hair dryer, in this razor, in microwaves, and things such as washer dryers. I mean, those are practical uses of simple motors. But then there are the bigger motors. The bigger motors, like generators. Generators can produce mass amounts of power, and we can even purchase some generators that can run a household for a little bit of time. But anyway, you still have the same setup. If you look right here, you have the magnets north and south, and you have the wire running through. And this is the same setup we've talked about before, where this wire is rotated. You send electricity through this wire, and you rotate it, and it makes it even bigger because it will change the magnetic field. The north goes to south, the south goes to north, and it's the same exact thing, just on a bigger scale. But you have to have something to keep the wire rotating. This has to be something that's rotated, and people can't just sit there and do that by hand. And if you get that very fast to get enough electricity, you want to have something that will do that. So the question is, what rotates the turbines? And what happens is, there are turbines that are a turbine is connected to this rod that makes the alternating movement. So there's, I mean, something as simple as wind power can rotate the turbines, which moves the electrical wire between the magnets. Something as simple as, when you have a hydroelectric dam, you have water which flows through and it rotates the turbines. And that's exactly what's happening. It rotates that long elongated area there, which is going to rotate the wires in the generator, which sends the power down through the wires. And that's exactly what is happening. Let's take a look at this next slide. And here's a type of generator you can purchase. Now, this is not going to be as big as something that'll light up a whole city block, but still you can plug into this generator because it's creating electricity, because you have the alternating current. Here you have a bigger generator, but if you notice, it looks very similar to these smaller these smaller simple motors. I mean, that looks almost very similar to this right up here. Same setup. I mean, you have magnets all around, and you have the rotating wire that is in, and you can even get some generators that are as big as this. Look at how big it is. We have a human that is standing there next to this generator, which produces a whole lot of power, I am sure. Hope you learned a little bit about these aspects of electricity.